Okay, I gotta make sure my sound is on there. This is the last video over graphs. And in this graph, we're going to do something called a scatter plot. And we're going to look at how we're going to do some statistical analysis of a graph, of a line graph, to provide us with some experimental values. So before we talk about that, let's go back and review your basic algebra. So I have a couple of graphs here that I created, and these are my x values. I just gave it 0, 1, 2, 3, 4, 5. For the first graph, I had these values. For the second graph, I had these values. And I show the equation of the lines right here. And we have this thing called this R value or R squared value. Well, hopefully you remember from algebra that the formula for the slope of a line is y equals mx plus b. And b is where it intercepts with the y-axis. So in this case, for this graph, our y-intercept will be 0. I'm giving myself some spaces here. The y value is the vertical axis. The x value is the horizontal axis. M is what we call the slope of a line, how fast the line rises over runs. So we take rise divided by run to get the slope. And there's a lot of instances in science where we'll have two variables we'll plot on the y and x axis, and this slope becomes a value we're looking for. So it's really important to be able to understand this equation in science. Now, when we graph it, we can create the equation of a line using Google Sheets statistical analysis. So where it says 4.02x plus 0.0762, what that equation is saying is that the slope of this line is y equals 4.02x plus 0.0762. So what that's saying is this the formula for the slope of this line. Here's my y value. If I put in any x value to get the y value, I would complete these calculations. So these are my y, these are my x. This is my y-intercept. It's almost at 0, but not quite. And this is my slope. Now I did a second one over here. Oh, so this gives me the equation for my line. Then over here, I have a value that is called the correlation coefficient. And this R squared value has a number behind it. And it ranges from 0 to 1. If there is a good correlation, and this is for linear graphs, the better the correlation between the data, the closer this is to 1. So this is a pretty good linear line, and it has a value of 0.996. So I did a second set of data over here. Now you can see right away that when I put a line through these points, that's not a very good looking line. The points aren't close to the line at all. And my value isn't even around 0.9. I got 0.857, which isn't very good. Anything good would be 0.9 and higher, maybe 0.95 and higher. Actually, 0.9 would be a little low. Well, the reason this has a bad correlation coefficient, again, R squared is the correlation coefficient, is because the relationship between these dots is not a line. I'm going to go into this graph and I'm going to change it a little bit. I'm going to have to, there we go. And I'm going to change it from linear to exponential, and look what happens. Ooh, that's much better. Now the line goes through the points. Because this doesn't have a linear relationship, this has an exponential relationship, and look what happened to my correlation coefficient. I have a really good correlation coefficient. So if your correlation coefficient isn't close to 1, you have two possible explanations. One, your data wasn't very good. It's just not related very well. Or two, you're using the wrong formula for your line. So you'll notice too, my equation changed a bit. I've got this 2.15e 0.6 to the 0.688. This is a different value than this. Now, the only thing we're going to look at for our purposes are linear graphs. But this just kind of illustrates what that correlation coefficient, that R squared value is. All right, let me show you how to make a scatter plot and how to get that equation and correlation coefficient value. So I'm going to select my data. I'm going to go to graph, and I've been doing scatter plots, so it already comes up as a scatter chart. But if it didn't, it was under suggested, but even if it wasn't suggested, you can scroll down and there is a graph that says scatter, and we will want to click on that. The axes are usually pretty well applied, but you notice I don't have any kind of a line through this. Well, I have to create that. So we're going to do that by going to Customize. We're going to go to Series. Underneath Series, I'm going to scroll down until I get to Format. Underneath Format Data Point, I'm going to put in Trend Line. There's my line. This lets me change the color, just kind of the cosmetics of it. But down here, we want to click the Show R-squared. This is Show Our Correlation Coefficient. And for our label, we want to put in, there we go. Sorry, up here for label, we want to put, I was on the wrong, there's label, custom label. So I want to do Show R-squared, and under label, I want to put Use Equation. Now I have that equation. So my slope is 0.196. My correlation coefficient is 0.986. That's not a bad graph. It's not great, but it's not horrible. You can see our line kind of splits the difference between some of these points, but overall, it looks like it's pretty usable. So in this case, the equation that for this graph that I would use in physics is velocity equals acceleration times time. Time is my x-axis, velocity is my y-axis. That means that my slope is showing me the acceleration of my object. Again, think about it. If we have, let's write these, y, and let's assume our y-intercept is 0. So if I have y equals mx and plus 0, because my y-intercept is 0, or I have v equals at, it's the same equation, just different variables, right? Now instead of x, I'm using time. Now instead of y, I'm using velocity. And my slope is actually a value. This is, if I wanted to find the acceleration of an object, I could graph these values and find that slope, and that would tell me the acceleration. Now, it's a little over our pay grade right now, but I wanted to illustrate that a lot of times this slope means something. It's not just something you solve for on your algebra test. All right, I'm going to size this down. I'm going to have you guys do a practice problem. So I'd like you to create a scatter plot for this data that I have here. I did height versus potential energy. Height is going to be my x-axis. Potential energy is going to be my y-axis. I'd like you to create a scatter plot with the trend line and the correlation coefficient. So go ahead, pause the video, and when you come back, we'll look at the solution. Okay, how'd you do? Well, let's select our data. We're going to insert chart. And I'm going to go to Customize, Series, scroll down. I want to add my trend line. The label, I want to use the equation, and I want to do R-squared. So this is the graph you should have created. Your correlation coefficient should be 0.988. Your equation would be 1.05x plus 0.019. That means my slope's 1.05. And I can use that then to find, again, this is another physics equation. So I know that potential energy, so we have y equals mx, that's the slope of my line, assuming our y-intercept is 0. Well, I know that potential energy is equal to weight times height. So if I have height here and I have potential energy here, what's my slope? This is the weight of the object. Again, this is a little bit oversimplified, but we're showing you that the slope has a meaning. There is a purpose to it. And my correlation coefficient's pretty strong. This is a pretty reliable graph. The relationship is definitely linear. Okay, so our takeaways here are sometimes if we're going to do a linear graph, we want to do a scatter plot and do what's called a trend line to give us an equation and that correlation coefficient. And that can tell us a lot about what we're trying to solve for and how well the data is related. Also, keep in mind that it isn't always linear. Sometimes we get relationships like this, and you have to remember that. Okay, Thanks for watching. That's all for now.